In match problems 9, 10, and 11, we're looking at a particular type of limit problem. In particular, we're looking at the limit of what's called the difference quotient. And this is defined as f of a plus h. So we're starting at some value for x. So a could be 2, 12, 0.5. So the difference between a plus h and f of a divided by h. So this is the difference quotient. Right now it maybe seems a little bit arbitrary, but when we start talking about derivatives, we're going to come back to this difference quotient as a very important topic. For right now, it's enough to know that this is what that general form is, and now we want to look at how do we evaluate limits of difference quotients. So in match problem 9, our function is f of x equals 7 minus 2x. We have the limit as h is approaching 0 of some rational function here. So we could start off by trying direct substitution. This would give us f of 4 plus 0 minus f of 4 divided by 0. Now, it turns out the numerator would be heading to 0, but really all we need to know is that the denominator ends up being 0, and that's enough to know that direct substitution won't allow us to solve this particular type of limit problem. So instead what we're going to do is write this out by actually plugging in the function itself. So this says f of 4 plus h. We're going to plug in f of 4 plus h. So this is going to be the limit as h approaches 0 of 7 minus 2 times, and in place of x, we're substituting 4 plus h, minus f of 4, which is going to be 7 minus 2 times 4. And I'm just putting that second expression in parentheses so that I know that negative sign is going to have to get distributed through there, or I'm going to have to first simplify what's in here and then subtract that. So just to make sure I don't lose track of my signs there, all over h. So we're not doing anything with the denominator. All we're doing is actually replacing this function notation with the function itself. So we're going to simplify what we have in the numerator. In this case, we're going to get 7 minus, distributing that 2 through the 4 plus h. We're going to get minus 8 minus 2h, and then distributing this negative through, minus 7 plus 8. So we had the option, we could have simplified what was inside these parentheses first. I chose to distribute that negative through just because it makes this next step a little more obvious. Now what we have in the numerator is 7 minus 7, 8 minus 8. So those are all going to cancel out with each other, which leaves us with the limit as h approaches 0 of negative 2h over h. So now h over h cancels out, and we have the limit as h approaches 0 of negative 2. So now we're taking the limit of a constant. Doesn't matter what h is approaching. The limit of a constant is always just that constant. So our limit in this case is negative 2. So we weren't able to evaluate this using direct substitution. That led to a 0 in the denominator. So when we encounter these difference quotient problems, that's always going to be the same issue. We're always going to have h in the denominator. H is headed to 0. So direct substitution will never work. The key to this problem was this step, where the h over h canceled out. So our goal for difference quotient problems is always going to be to figure out how do we cancel the h in the denominator? And that's a question. How do we cancel out that h in the denominator? Depending on the problem we're considering, that approach will differ. We'll look at a couple of examples here, but that's really the goal. Cancel out the h in the denominator, like we did in this step, and then what we're left with should be a limit that we can actually evaluate.